Hello. So this time what I want to do is I want to make this robot steer toward the light with the simplest form of navigation. Simply looking to see if one of these sensors has a value that is actually less than the other. Some sort of threshold here so that we're not just constantly going back and forth. So in other words, the difference between these two sensors has to be in excess of some value. And then we're just going to call simple little steps to the left or to the right, with the default being forward. So if it looks great, it's just going to go ahead and go forward. If one value gets greater than the other, it's going to nudge it to the left or to the right with an if-then statement and eventually kind of work its way over to it. So it's a real simple method. I have an example here. I call it simple autonomous navigation. And again, what I'm going to do is copy and paste all of this code into a window here, or I'm sorry, into a sketch. And actually, I'll just use the same one I was just using. Oh, my delete me one. And let me go ahead and load this up and I'll pause it. So I'll see you in a second here. Okay, so I've got it loaded up. Let's quickly go over the code, and actually we're going to back up a teeny bit before we run it. Of course, I've got my servo.h, and I've created my two servo objects, left servo and right servo. I have my sensors, my left and right photo sensor, the sharp sensor. I've turned on the onboard LED. I'm sorry, I haven't turned it on yet. I've declared the onboard LED, the one that's built right onto the chip, which is hooked to pin 13, called it LED. And then I'm going to make a couple of variables here to store some information. This is where we're going to store the value that we acquire from the sensors that we have hooked up. Setup is pretty simple. Open up a serial port in case we need to do some diagnostics. I have to make sure the LED port is set to output so we can turn on or off the light. I'm going to attach my servos. This is really critical. I did move mine. So I'm on pins 2 and pins 1. You need to make sure that you match up your pins with your servos. And then I have this little thing here where it's going to flash the onboard LED 4 times before it actually takes off, which of course is also really nice. If the processor is resetting and you see the light flashing in mid-operation, you know your batteries are simply not handling it. They're dying. They need to be recharged. Okay, and then this is the part that's going to take a lot of modifications for your own robot. This is the settings that work for me. Yours are going to have to be different. We're going to play with them for a minute. I've created some functions here. I've got forward, and I've got an argument called delay. So in other words, I can call it so that it holds the forward command for 20 milliseconds or 10 milliseconds or 5 milliseconds before it re-queries what's going on. Okay. Keep in mind, anytime you call the right microseconds and put in a value, it stays running until otherwise. This just means that I'm going to delay the looking for another value for some period of time. So it's going to run at least 20 milliseconds or at least 10 milliseconds or whatever value that I put into this argument. And then it'll move on its merry way. I've got one for reverse, which I just threw in there. I don't think I'm going to really need it. I've got a stop one where both of them set to 1500. Yours may not stop at 1500. You may have to play with that. I've got a slow turn left or turn left slow. Mine, I put at 1500 and 1600. In other words, in this particular case, I'm actually just going to stop one wheel while slowly rotating the other. So I'm not going to do a 0-point radius. I'm actually going to do an arc. I found that works a little bit better for what I was playing with. Same thing here. I stop one wheel and I make the other one turn. So instead of it just rotating like this, it does an arc. My check sensors. Okay, I take the value of the two photo detectors. I look for the difference because I am going to be looking for some sort of threshold. I want to see some value where there's a difference between the two in excess of some number, and I get rid of the possibility of negatives by making it the absolute value. I gather the data into the sharp, and in fact here, right here in the check sensor, I make the decision as to whether or not the robot's even going to proceed. Okay, so as it checks sensors, if the sharp value exceeds 500, which for my robot is about like that, maybe like that, it simply stops for 1 second. And then, of course, it's going to hold it there for 1 second. Then it's going to re-enter the loop. But if the condition is still true, it's going to stay stopped. Although you might see it when I do a demo, jerk just ever so slightly because it exceeded 500, like 505 or 510. And then the second reading, it was 490, and it nudged forward a teeny little bit. But ultimately, it stops. For diagnostics, I've got a function called print sensors, which is outputs that data. Again, I don't like to print things in robot motion because it tends to slow it down. And here, of course, I have the loop, and it's going to check the sensors. And then, actually, we're going to hold off on this because I want to show you how I calibrated my robot. Let me take and all these down here and comment it out. And what I want to do is I want to run just the forward and see what it looks like. I can leave the check sensors in there. That only takes a couple of microseconds. And let's go for, I don't know, 20 milliseconds. Doesn't really matter. And I will load that up and I'll pause it. So I'll see you in a second here. Okay, so here you can see I have the robot going just forward. Okay, it's going in 20 millisecond pulses, although for all practical purposes, because I'm not telling it to do anything else, it's just running. Okay, it's running forward. And what you're going to need to do is you're going to need to be able to construct these functions for your individual robot. And it's tedious, I admit it. I mean, for example, just changing this to a 1400 will make a dramatic difference in the operation of at least one of those wheels, as you're going to see right here. We have to wait for the light to flash. Alright, so that's veering off quite a bit. You have to play with it and create individual functions for your robot. Also pay attention to, I've actually chosen in all of these cases, I might have said this before, but I'm actually just going to rotate one wheel. So I stop one wheel and I rotate. Stop one wheel and I rotate. So let me pause this and set up the next thing. I'll be right back with you. Okay, so I've tweaked in all of my different functions here. I've got a real nice turn left slow, turn right slow, and a forward, which I'm happy with. Now what I'm going to do is I'm going to bring back all of this, and then I'm just going to get rid of my little forward test here, okay, and load that up, and then I'll give you a demonstration of how it works and explain to you the code. So what it does is checks the sensors, okay? Very first thing it does, it checks and gets all the values of all the sensors. Then it says, well, wait a second, I need to have some value coming into the photo detector. And right now, if it's facing away from the photo detector, from the light, I'm sorry, it's going to just slowly turn to the left until the left photo sensor gets in a value greater than, while it's greater than 1,000, in other words, it doesn't see anything, it's going to turn slowly to the left, constantly checking the sensors. Okay, so once it finds something, though, it breaks from this while loop and it takes off comparing the two sensors. Okay, so it's constantly checking the sensors. Check the sensors again, and then it says, well, wait a second, if the value difference is greater than 70, in other words, we don't agree, okay, there's a great difference between the left and the right, then I ask the question, is the left greater than the right? If the left is greater than the right, well, let's turn slowly for a little bit. Okay, you may have to play with these numbers quite a bit. If your robot is going faster than mine in turning left or turning right, you're probably going to want to make these numbers smaller. If your robot is going really slow, you may want to make them a little bit bigger. You can play with it to get that worked in. And of course, once again, if the difference between the two is greater than 70, and the left is not greater than the right, the assumption is that the right must be greater than the left, and it turns the other direction. Okay? If the difference between the two is not greater than 70, okay, and the value is, of course, in with a threshold so that it assumes that it sees the light, well, the only thing left to do is to go forward. All right, so it goes forward for a little bit. And then it gets into the loop again, over and over and over again. It checks the sensors. This stuff should be okay because it should have found the light, and never goes to it again. It compares the left and the right, and then it checks to see whether or not there's a difference, and then if not, it goes forward, and if there is, it makes this light twitch to the left or to the right. So let me actually get this guy running, and I'll see you in a second. All right, so let's give this a try, and I'm aiming away from the light, and once it finds the light, it does that jerky motion, slowly getting closer until the sensor gets to 500. And let's try that again. Make it steer further away. Moving back and forth until finally it gets there. Okay? A little messy, but I think you'll agree that it will actually find the light. And so let me do another one where it gets a little bit smoother. So I'll see you in just a few minutes.